All right, today we're jumping into one of the most debated ingredients out there, palm oil. I mean, this stuff is everywhere, but the advice on whether it's good or bad for you, well, that's a whole other story. Seriously, just look around. It's in about half the stuff you see in a supermarket. Cookies, makeup, you name it. And yet, for as long as I can remember, we've heard warnings about the health risks. So what's the real deal here? The official advice seems pretty straightforward. But when you actually dig into the science, whoa, it gets way more complicated. It's a story about chemistry, about context, and honestly, some pretty surprising findings. So let's unpack this, starting with the main concern.
All right, Section 1, the palm oil puzzle. So what is the big concern? Why does palm oil get such a bad rap when it comes to our health?
Okay, it all really boils down to this chart right here, the fatty acid makeup of palm oil. A whopping 50% of it is saturated fat. And that's a lot higher than what you'd find in other common oils like olive oil or sunflower oil.
And that high saturated fat number is precisely what sets off the alarm bells. The American Heart Association, for example, is super clear on this. They draw a straight line from eating too much saturated fat to higher levels of LDL, that's the bad cholesterol, which, as we know, increases your risk for heart disease and stroke.
In fact, they get really specific about it. The recommendation is that less than 6% of your daily calories should come from saturated fat. So if you're on, say, a 2,000-calorie diet, that's only about 13 grams a day. And when an oil is literally half saturated fat, well, you can see why it becomes a major focus. So, okay, case closed, right? Palm oil has lots of saturated fat. Saturated fat is bad. Simple. Well, not so fast. This is where the story starts to get a lot more interesting. All right, let's dive into our next section, which looks at adult health, but through a different lens, the glucose question. We're going to see how palm oil stacks up when we look at a totally different health marker in a very specific group of people. So back in 2019, a group of researchers published a big systematic review. And what that means is they basically did a study of other studies to see what all the combined evidence had to say about how palm oil affects things like fasting glucose and insulin. And let me tell you, their process was intense. They started with almost 2,000 different articles and whittled them down, filtering and filtering, until they were left with just the 8 most relevant, high-quality studies. So this wasn't some casual glance, it was a really deep, thorough investigation. So what did they find after all that work? Well, this is the kicker. When they pulled all the data together, they found that in healthy adults, there were no significant differences in fasting glucose levels between people eating palm oil and people eating oils we usually think of as healthier, like olive oil or soybean oil. Now, this takeaway is absolutely critical. What it suggests is that if you narrow the focus to this one specific health measure, glucose metabolism, and in this one specific group, healthy adults, then suddenly the argument for replacing palm oil kind of falls apart. It shows that context is literally everything. Okay, but now we're going to flip the script completely. Let's talk about the infant formula story. Because when we shift the context from healthy adults to infants, the role of palm oil takes a really dramatic and very, very different turn. See, for babies, the big deal isn't just about the amount of fat we're talking about. The real key, the thing that changes everything, is the molecular structure of the fat itself. And to get this, we need a super quick chemistry lesson. So fats are carried around on this molecule called a triacylglyceride. The easiest way to think about it is like a little backbone that has 3 parking spots for fatty acids. And these spots are called SN1, SN2, and SN3. Now, where a fatty acid parks makes a huge difference in how our bodies can actually absorb it. And this right here is the whole ball game. In human milk, most of the palmitic acid, about 70% of it, is parked right in that central SN2 spot, which is super easy for a baby to absorb. But in palm olein, which is what's often used in infant formula, that same fatty acid is stuck on the outside spots, SN1 and SN3. It seems like a tiny difference, but believe me, it changes everything. So here's what goes down inside a baby's tummy. Enzymes come along and they snip off the fatty acids from those outer spots, SN1 and SN3. But now you've got this free palmitic acid floating around, and what does it do? It grabs onto calcium in the gut and forms these little insoluble clumps. They're actually called calcium soaps, and the baby's body just can't absorb them. And this one little chemical reaction causes a whole chain of problems. The infant ends up absorbing less fat and less calcium. The lower calcium absorption can affect bone mineralization, which is obviously critical for a growing baby. It can lead to harder stools, and some studies even suggest it might be linked to reduced weight gain. And all of this just because of where one fatty acid was parked on that molecule.
Okay, let's bring it all home. We've got a tale of two very different contexts, with two very different outcomes. So what's the final verdict on palm oil?
This table really sums it up perfectly. When we're talking about general adult health, the American Heart Association's advice is clear: limit saturated fat because of the cholesterol risk. But when we narrow the context to glucose metabolism in healthy adults, the research shows no significant downside compared to other oils. And then for infants, the specific chemical structure has clear negative impacts on how they absorb nutrients and build strong bones. So let's circle all the way back to that first question: is palm oil unhealthy? By now, I think you can see that a simple yes or no is not just unhelpful, it's just plain wrong. The only real accurate answer is it depends. It depends on who is eating it, because an adult's body is not the same as an infant's. It depends on what health outcome you're even looking at. Cholesterol isn't the same as blood sugar. And as we saw, it absolutely depends on its specific chemical structure. And that really leaves us with a bigger question to chew on, doesn't it? We've just seen how a single ingredient can be totally fine in one context and potentially harmful in another. So if that much detail and nuance matters for just one ingredient, maybe it makes you think, how should we approach all the nutritional advice we hear every single day?